So this is sound. Okay, so today's topic is sound. Okay, so we are going to learn about the sound, how is it produced, how is it produced, and how it is propagated from one place to another place. Means source, from source, sound source to the object, the listener. Okay, so let's go. So sound, this is originated from a source that is vibrating, that is working like a periodic motion. Okay, so periodic motion means the type, the phase, the nature of the motion is repeating after a specific time. That is the periodic motion. Means if we say for one object or for one motion, the time period is 2 minutes. Means after 2 minutes, the nature, the position, and the speed of that object is going to be same only in after each 2 minutes. Okay, so see, so production of sound, so this diagram will show much better. So you can see here what is showing: vibrating ta- vibrating tuning fork. So it is vibrating means it is moving from one direction to another direction and coming back to the same direction. Okay, so this is happening with time. So another thing here, through by thread, some table tennis ball is hanging, right? So when we stretch or try to stretch the vibrating tuning fork to the right side, okay, so we are taking right side, so it will come back after some time in the left side as well. So it will hit the tennis ball. So what will happen, the tennis ball will move away and it will go as high as possible to a specific height. Okay, so this will be repeated. Okay, as the vibrating tuning fork is vibrating, means it is completing a specific motion, specific type of motion with a specific time. Okay, so this is the vibration means. Okay, now this is making a sound. So this sound is going to be propagated through the media. It may be liquid, it may be solid, or it may be gaseous. So in this case, if we have kept this vibrating tuning fork in the air, so eventually the sound will propagate through gaseous system. So what happens, the speed of the sound is varied, is variable. Okay, so what happens in through solid it is highest, and through liquid it is less, and in case of gaseous system it is lowest. Okay, so we need to remember this thing. So this is the basic source of sound. Okay, so vibrating, something vibrating usually makes some sound. Okay, so see, so you can see the vibrating tuning fork is kept above the glass of water. So it is vibrating now longitudinally, right? So what will happen, it will make the water also to vibrate. Okay, move, movement will occur inside the water also. Sorry, so see, wait, so in this way also same thing, but the movement of water is different. Now the movement of water is in the horizontal direction, right? But in this case it was longitudinal, right? So the movement is different. Okay, so now propagation of sound. So now propagation of sound, during the propagation of sound, what happens, the figure will show the best one. Wait, not this. Okay, okay, so see here what is happening, the vibrating tuning fork is there. The tuning fork is vibrating horizontally, right? And horizontally, when it is vibrating, then it is making some pressure, it is pushing some pressure on the air, just uh, just beside its location, right? So what happens in the air media is going to condense, right, to a some extent, because the pressure is applied on that material. So this is the constriction phase. Okay, so this is the constriction phase. And another thing, you can see when the vibrating fork uh, come back its original location and goes in the opposite direction, so the air present in the gaseous system will now get dilated, right? So this dilation means constriction and dilation. So this will happen simultaneously, means one by one. On time constriction, then after dilation, then again constriction, then dilation. This will happen. And another thing, the constriction and dilation of the air is same in the same direction of the tuning fork vibration, right? You can see it is horizontal direction. So that's why it is said as horizontal wave, or it is said to be longitudinal wave. Okay, so it is longitudinal means same in the same direction, whether in the whatever the direction of vibrating fork is there, so same direction is in the air also. That's why it is longitudinal wave. Okay, so she wait. Okay, so sound needs a medium to travel. Yeah, we have discussed, because the sound and the propagation of sound is occurring through the specific medium vibration. The vibration is also seen in the medium like air, water, or something like solid substance. Maybe it is steel or like iron. Yeah, so that's why sound needs a medium to travel. Okay, so I have discussed already, these are longitudinal because the movement of the tuning fork or vibrating fork or the source of the sound is same with that of the movement of the medium. That's why it is longitudinal waves. Okay, so you can see here spring is constricted and dilated. Okay, constriction and resolution, that is occurring in the longitudinal phase, right? In the horizontal direction, so it is happening. Okay, so characteristics of sound wave. So sound wave is propagating through a system, so it will must have some speed or velocity, and it will have also frequency or amplitude. So I will discuss the frequency means the how much number of wave is formed in unit time, that is frequency. In unit time, how many waves are formed, that is frequency. So you can see in this figure, this will help you better. So you can see the lowest one. Okay, so what is happening here, the average is density. So the wave is moving, so wave is moving from one place to another place, but you can see the lambda is written means that crest of the wave adjust the distance between most adjacent crest, that is the lambda, means wavelength. This is called as wavelength. Okay, and this wavelength, we got wavelength, and the speed we know, the speed means in unit time how much distance the wave is covering, that is the speed. Okay, so another thing is the frequency means in unit time how many this crest type of thing is propagating through a particular space. Okay, so that is the frequency. So you can see in the wave, it is crest, the upper part, and the lowest distance means negative direction. In the negative direction, this is known as trough. Okay, trough. So the highest distance between the median line to highest crest, that is the A, means amplitude. Amplitude is the distance between the median line and the highest point like crest or trough, that is amplitude or A. Okay, so the unit of frequency is hertz. Okay, this is actually SI unit per second is known as hertz. Okay, so nu is 1 by t. Here on nu is 1 by t means t is that t is the time period. Okay, so time period means the time taken to complete a period or complete a movement. Okay, from one place it is started the motion, and after coming back to that place, that is the on period. Okay, and the nu means the frequency, so frequency is 1 by the reciprocal of period. So here wave shape for a low pitched sound. So here with time the wave is moving from one place to another place. So you can see this one and this one. So here what is happening, the wavelength is much higher than this one, wavelength is less because the distance between two crests is here less, right? So that's why the wavelength is less here. So wavelength is less. If wavelength is less, that means the frequency is high, means in each second more number of wave is formed. Okay, you can see here very dense type of wave is formed in each second. Much more number of wave is formed, that's why the frequency is high. Okay, so frequency and wavelength is not proportional, irreversibly proportional. If wavelength increases, the frequency decreases. Okay, so this, so you can see v is equals to n lambda, means v is the speed of the sound or speed of the wave is equals to n lambda, means n is the frequency and lambda is the wavelength. So if speed is equals to wavelength into frequency of the sound or wave. Okay, so we have discussed already that in the solid the speed is highest and liquid it is less, and in case of gaseous it is the lowest. Okay, so reflection of sound means sound is coming from one source through one media, specific media, and it is getting reflected, means coming back to same media after attacking or after hitting a wall or wall like structure. So like you can see, you can imagine you are making sound and this sound is propagating through air, and this after propagating some distance all is there. Okay, so room wall is there, so it is hitting the room wall and again coming back to your uh, ear. So this is the reflection. Okay, so coming back to the same media from where it is going. Okay, so reflection of sound. One thing, our memory is capable of detecting two separate sound if these two sound comes after 1 by 10 seconds, sorry, 10 second, after 10 not 10 seconds, okay, sorry, 1 by 10 seconds. So 1 by 10 second, if two sounds come after 1 by 10 seconds, then we can easily detect two separate sound. But if two sounds coming together within 1 by 10 second, then for us it is impossible to detect separately. We will feel like only one sound came. Okay, so this is the reason, because this is the reason behind echo. So when we hear some echo, that means the source sound listened, and after more than 1 by 10 second it took to come another sound of same frequency or same sound is coming back after reflection. Okay, So echo. So we need to remember the speed of sound, that is 332 meter per second. It is standard form. In the standard form we use 332 meter per second. Okay. So it is the application. Stethoscope works on the principle of sound reflection. Means sound is created, or sound is formed there in the heart, then the sound is coming back to our ear. Okay, so we can listen repeatedly by reflection of that sound many times. Okay, stethoscope. So range of hearing, we cannot listen every frequency of sound. Okay, so we only listen to 20 to 20,000 hertz. So above the 20 hertz we can't listen, and even lesser than 20 hertz sound we can't listen. So that's why the range is there. So at 1 kilohertz means 10 to the power 3 hertz. Okay, so if it is more than 20,000, okay, 20,000 hertz, then we can't listen. That is known as ultrasound. Okay, so this ultrasound is used in case of USG, ultrasonography. So in case of ultrasonography, the sound produced inside our body organs is not make sense to our ear, but it is detectable by the ultrasonographic instrument, because it can detect more than 20,000 hertz of sound. Okay, so ultrasonography is based on ultra sound, that is more than 20,000 hertz. Okay, so the acronym sonar stands for sound navigation and ranging. Okay, so by this, we in a boat or ship we can understand the distance of hill or something obstacle. Okay, so if we make sound, then it will go to that obstacle and it will get back after reflected. Okay, after reflection, sorry. So that's why after by using sonar means sound navigation and ranging, we can know the place or location of the hill. Okay, so sonar is used in ship. Okay, so thank you.